Hello and welcome to Stats C1000 here at Kenyatta College. My name is Lapuz. In this video we're going to take a look at finding sample sizes to help find the proportion, and this is coming from section 8.3. This problem says you plan to conduct a survey on your college campus to learn about political awareness for students. You want to estimate the true proportion of college students in your campus who voted in the 2020 election with a 95% confidence and a margin of error no greater than 5%. Now, if you remember the error bound formula, let's see if I remember the error bound formula. I believe the we're in the highlighter mode. The error bound formula says that error bound for the proportion is equal to some z sub alpha over 2 times the square root of pq divided by n, or p hat q hat divided by n. So what we could do here is to figure this out, we're going to solve for n, and without doing all the tedious algebra that you would need to solve for this, I'll just say that the n is actually equal to z sub alpha over 2 times p prime q prime, all divided by n. And I think this is squared. Yeah. So it's going to be the critical point squared and then pq over n. Now the thing is that knowing pq is usually not readily given to us, and so there is a chance that we might not know PQ. And as I scan these sentences in this paragraph, I don't see any information about a possible P prime value. So for us, we're going to make a note that says there's no P prime given. So we're going to assume that P prime is going to be 0.5. So 0.5 generates the largest possible P prime there is, and the largest possible P prime times Q prime combination, which, if you have no information, you want that to be your marker for P prime. So if you make your sample size too small, then your sample might not be valid. So we want it to be as large as possible just to be safe, unless we know a given P prime that might have worked in the past. So we don't know that, so we're going to assume that it's equal to 0.5. All right, now let's find the rest of the information. For the rest of the information, let's read through it again. You want to estimate the true proportion on your campus who voted in 2020 with a 95% confidence. So your confidence level is going to be 95%. And that's going to help you find your z sub alpha over 2. And I think we know what that is because we've seen it quite a bit, but let's leave it like this for now. And then and a margin of error, so this is going to be the error bound for the mean, EB, not the mean, but the proportion, so EBP, no greater than 5%. So 5%, we have to write this as a decimal whenever we do work and do some formulas with it. So we'll have our EBP to equal 0.05. Okay. So now let's go to our, there's the link here. It's supposed to be a link here, but it's missing. Let's see if I can find it. There it goes, magically appearing. Here's a link to our calculator. Now our calculator has several tabs in the bottom. We want to look for 8-3 determining sample size for proportion. And here are the things that we need. We need the error bound for the mean, or for the proportion. Sorry, this should be EBP, error bound for the proportion. A given sample proportion. Note, if it's not given, we're going to input 0.5. Q prime here will automatically be calculated. You can do it yourself. It's 1 minus P prime, and then enter a confidence level. That's going to give us our z sub alpha over 2. All right, so what is our error bound? So 5%. So let's put 0.05 here. That gives a 5%. Our sample is not given, the sample proportion, so we're going to assume this is 0.5, and automatically Q is going to be 0.5, and then our confidence level was 95%, 0.95, and then we get our Z sub alpha over 2 as 1.96, and then now our sample size gets really big. It calculates to 384.1, but we always want to round up. So this is a rounding up function. If you want to know what that function is in Google Sheets, it's called roundup, and then you put in whatever value you want. So we round up, and then it goes up to 385. Okay, so just to put our Z sub alpha over 2, not that we need it for our final answer, this is 1.96. And then your N, therefore, N is equal to 385. Okay, that's it. I hope that helps. Good luck.